let's say I have 0.110. For 3 digits, if I want to know the CDF for point x1, x2, x3 being less than or equal to 0.110, then what can I have? If the first digit is less than 1, then it's for sure less than or equal to 0.110. If the first digit is equal to 1 and the second digit is less than 1, then for sure it's less. If the first digit is equal to 1, the second digit is equal to 1, and the third digit is less than or equal to 0, then that's the only other possibility. So generally speaking, we have the following kind of expansion. So the CDF of point x1, x2, x3, and so on up to xn being less than or equal to point little x1, little x2, and so on up to little xn is equal to, well, if the leading digit is less than this one, then that's for sure less. If the first digit is equal and the second digit is less, that's for sure less. If the third digit is if the first two digits are equal, and the third digit is less, then that's for sure less, plus, and so on. So basically you're looking at at what point the digits start to be less than this value. So you can have the first digit equal and the second digit less, first two digits equal, the third digit less, first three digits equal to the fourth digit less, and so on, until you get to the end. You have probability of all the digits being equal up to n minus 1. And the last digit being less than or equal to. So that's the general formulation of the CDF. Now, it turns out, conceptually this is simple. It turns out it has quite a simple way to write it down. To see that, let's look at the following specific example. So let's say let's let probability of 0, probability of 1 equal p, probability of 0, which is equal to 1 minus p. Let's just assign that the value q. Okay, so if I want f of x1, x2, x3, x4, x5 being less than or equal to 0.01101, and I want to get that through this formulation, I look at the first digit first. This is the probability that x1 is less than 0. So that's as the first term. What's the probability that x1 is less than 0? That's impossible, so this must be 0. Plus the probability that x1 is equal to 0 and x2 is less than 1. If x2 is less than 1, what must it be? It must be 0. This is a binary system. The only possibility is 0. So this is basically saying this is the probability of x1 equals 0 and x2 equals 0. Which is, what is that? If they're IID, what is that?
B squared.
It's q squared.
Plus.
Plus probability x1 equals 0, x2 equals 1, and x3 is less than 1. So if x3 is less than 1, then it can only be 0. So this is equal to the probability of x1 equals 0, x2 equals 0, excuse me, x2 equals 1, x3 equals 0. Which is equal to,
BQ squared.
yes, it's, well, it's q, p, q. So q squared p. It's however you want to write that down. Plus p x1 equals 0, x2 equals 1, x3 equals 1, x4 equals 0. Excuse me, x4 less than 0. Just looking at that last term, it's impossible for x4 to be less than 0, so this is all 0. Plus dx1 equals 0, x2 equals 1, x3 equals 1, x4 equals 0, and x5 less than or equal to 1. So x5 can actually take two values here, 0 and 1. I'm going to split this up into x5 less than 1, which is, that's q, p, p, q. x5 being less than 1 is x5 equals 0, so that's q. So q, p, p, q, q is q cubed, p squared, plus x1 is 0, x2 is 1, x3 is 1, x4 is 0, x5 equal to 1, which is q squared p cubed. So in the end we get 0 plus q squared p. Actually, I'm going to explicitly write down the zeros. Q squared p plus 0 plus q cubed p squared plus q squared p cubed. Now this is equal to the probability of 0, 1, 1, 0, 1 as a sequence. These we can get from a formula. The formula arises from noting that at each stage, so at stage 1, remember I had probability x1 less than the value of x1. So if x1 equals 0, then this is just 0. And if x1 equals 1, then this is probability of x1 being less than 1, which is just the probability of x1 equal to 0, which is q. So we get either 0 or q, and we get 0 if x1 is equal to 0. So we could actually write this as x1q. Second stage, probability x1 equals the specific value of x1, and x2 is less than the specific value of xq, x2,